Hello students, I am Laxman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in this hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. We will start with a new chapter, the structure of atom. Today we shall discuss about some of the atomic models. In this we will discuss the Thomson model, the Rutherford model, and then we will discuss about radioactivity also. In our previous lecture we discussed about the Thomson's charge upon mass ratio. Then we studied about the protons and the properties of protons as well as the electrons. Let us take a quick recap of what we had discussed the previous day. Then we'll start with today's topic. J.J. Thomson's experiment. This experiment was done to find out the charge to mass ratio of electron. In our previous lecture, we had studied that the cathode rays gets deflected in the electrical field as well as the magnetic field when they are applied perpendicular to the direction of flow of the cathode rays. Now, the same principle was applied by Thomson to find out the charge to mass ratio. J.J. Thomson measured the ratio of electrical charge to the mass of electron by using the cathode ray tube. By applying the electrical and magnetic field perpendicular to each other as well as to the path of electron. The electrons are moving from left to right, that is the cathode rays are moving from left to right through the perforated anode, okay, so that we get a beam of cathode ray only. That's why we have got a small opening at the center or hole at the center through which a beam of cathode ray travel in straight line. In absence of any electrical or magnetic field, the cathode ray falls on point B on the fluorescent screen. So whatever the glow will be seen or the blip will be seen, it will be seen at point B only, which is at the center in straight line. In the presence of electrical field which is perpendicular to the direction of the cathode ray, it will be attracted toward point A. The deflection will be seen in the cathode ray and the beam will start to fall at point A. And in presence of only magnetic field, the beam will bend toward point C. This will be more clear when we see the individual figure or the diagrams. Thomson was able to calculate the charge upon mass ratio from the fact that when only electric field is applied, the electron deviates from its path and hit the screen at point A. Similarly, only in the presence of magnetic field, the electron strikes the screen at point C. By a careful balance of the electrical and the magnetic field strength, it was possible to bring back the electron to the path followed as in the case of absence of electric and magnetic field. In that case, The cathode ray would hit the screen at point B. By carrying out the accurate measurement of the amount of deflection observed by the electron on the electric field strength or the magnetic field strength, Thomson was able to determine the value of charge upon mass ratio, and it was calculated as equal to minus 1.758820 into 10 power 11 coulomb per kg, where m e is the mass of electron in kg and e is the magnitude of charge on the electron in coulomb. Since electrons are negatively charged, the charge on electron is minus e. This is how the charge upon mass ratio was calculated. Discovery of protons and neutrons. After the discovery of electrons, there was a need to look for oppositely charged particle since atoms were neutral. For this, electrical discharge were carried out in the modified cathode ray tube that led to the discovery of particles carrying positive charge, also known as the canal rays. It is because the cathode was perforated, so these rays were called the canal rays. The properties of the positive charged particles are similar to that of electrons. However, there are few differences. Unlike the cathode rays, the positively charged particle depended upon the nature of the gas present in the cathode ray tube. These were simply the positively charged gaseous ions. When the cathode ray hits the gaseous particles, the positively charged gaseous ions are generated in between the cathode and the anodes, and they are attracted toward the cathode. The charge to mass ratio of the particle is found to depend upon the gas from which these originate. As a result, the charge to mass ratio differed when different gases were taken in the cathode ray tube. Some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. Depending upon how many electrons are knocked off from the gaseous particle, the ions may carry multiple charges. In electrical field, they move toward the negative electrode. That means they carried the positive charge. The smallest and the lightest positive ion was obtained from hydrogen and was called the proton. And in fact, the charge upon mass ratio was highest in the case of hydrogen. After the discovery of two oppositely charged particles, scientists thought how these particles present in a very small atom without disturbing each other. So, it was Chadwick who discovered neutron also. Now, let us start with today's topic. Now, let us discuss the atomic models. After the discovery of subatomic particles with positive and negative charge in the Dalton's indivisible atoms, the question was how to fit in these subatomic particles in the atoms. For this, different atomic models were proposed to explain the distribution of these charged particles in atom. However, some of them could not explain the stability of atom. We would be discussing a few of them. We'll be discussing, in fact, the Thomsons model as well as the Rutherford model. Let us discuss Thomson's model of atom. It was given in around 1898. He proposed that atom is spherically shaped with the mass and positive charge being uniformly distributed in the atom. The electrons were considered to be embedded into it in such a way as to give the most stable electrostatic arrangement. We give different names to this model like plum pudding model, raisin pudding model, the watermelon model, and so on. Although this model was able to explain the overall neutrality of the atom, but it could not explain the later experimental results. In fact, Thomson was awarded Nobel Prize for Physics in 1906 for his investigations on the conduction of electricity of gases. Let us first see the Rutherford's alpha particle scattering experimental setup. In the figure, we have on the left hand side the source of alpha particle from where the alpha particle is generated. At the center, we have the lead plate with a small hole at the center so that only a single beam of the alpha particle is allowed to pass through it, rest all the rays are blocked. And these single beam of the alpha particle is allowed to fall on the gold foil at the center of the photographic plate. The dotted lines are the deflected or the scattered beam of alpha particle, which when falls on the photographic plate produces scintillations, and these can be observed on the photographic plate from where the deflection can be measured. Now we will discuss the observations of this alpha particle scattering experiment. Rutherford and his students bombarded a very thin gold foil with the alpha particles. Now, what were the observations made in this experiment? Most of the alpha particles passed through the gold foil undeflected. They passed through the gold foil in straight line without undergoing any kind of deviation. A small fraction of the alpha particle was deflected by a very small angle. However, a few of the alpha particles, one in around 20,000, bounced back. That is, were deflected by nearly 180 degree. That was totally unexpected. So these were some of the observation. Now what did Rutherford make out of this observation? Now what were the conclusions drawn by Rutherford regarding the structure of atom after his alpha particle scattering experiment. Since most of the alpha particle passed through the foil undeflected, which meant that most of the atom was empty. Since it did not experience any kind of repulsion, that means most of the space inside atom was unused, or it was all empty only without any kind of masses. A few particles were deflected, and these alpha particles, they are quite heavy particle. They are helium ion, doubly charged, okay, and they are quite heavy particles. If they are deflected, that means the deflection must be due to the enormous repulsive forces, showing that the positive charge of the atom is not spread throughout the atom as Thomson had presumed. Because if the positive charge was distributed in the atom, repelling or deflecting the heavy alpha particle would not be possible. So it was assumed that the positive charge has to be concentrated in very small volume inside the atom, which caused the deflection of the alpha particles. Rutherford, by his calculation, showed that the volume occupied by the nucleus is negligible as compared to the total volume of the atom. He calculated the radius of atom to be around 10 inverse 10 meter, whereas the nucleus had the radius of around 10 inverse 10 meter. So the nucleus was very small as compared to the total size of the atom. On the basis of the experimental evidences and observations, Rutherford proposed the nuclear model of atom, and according to this model, the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This small portion of the atom was called nucleus by Rutherford. The Rutherford proposed that the nucleus is surrounded by electron that moved around the nucleus with very high speed in circular path called the orbits, thus resembling the solar system, and hence this model is also called the planetary model of atom. The electrons and the nucleus are held together by the electrostatic forces of attraction. According to the calculations done by Rutherford for the mass of atom, it was felt that some kind of electrically neutral particle should also be present in the atom. These particles were discovered by Chadwick when he bombarded a thin sheet of beryllium by alpha particle. Beryllium, atomic number 4, mass number is 9. When it was bombarded with helium, atomic number 2, mass number 4, it gave carbon, atomic number 6, mass number 12, plus one chargeless particle with mass almost equivalent to that of the proton was emitted. This particle was named as neutron. Radioactivity was discovered by Henry Becquerel. What is this radioactivity? The spontaneous emission of radiation on their own is called radioactivity, and the elements showing these are called the radioactive elements. It is observed that in the case of radioactive substances, three kinds of rays are emitted: the alpha rays, the beta rays, and the gamma rays. The radioactive substances, when they are subjected to the electrical field, it is seen that the beta rays, they are attracted toward the positive plate, whereas the alpha rays, they are attracted toward the negative plate of the electric field, whereas the gamma ray, they remain unattracted toward any of the electrical field. The alpha rays, which were attracted toward the negative plate, consist of high energy particle carrying 2 unit of positive charge and 4 unit of atomic mass. Since when an alpha particle combined with 2 electron, it gave helium gas. The beta rays, they were attracted toward the positive plate. These are negatively charged particles similar to the electrons, whereas gamma rays, which remained undeflected in the electrical field, are high energy radiations like X rays and are neutral and do not consist of any particles. If we compare the penetrating power of the three radiations, then it is seen that the alpha particle has the least penetrating power, then is the beta rays, and the highest penetrating power is that of the gamma rays. In term of the comparison, the beta particles are around 100 times more penetrating than the alpha particle, whereas the gamma rays are around 1000 times more penetrating than the alpha particles. The alpha particle can be stopped by a paper or it can be stopped by the skin, whereas the beta particle requires around 3 to 5 mm of aluminum sheet, whereas the gamma rays or the X rays, they are stopped by thick lead plate. Today we discussed about the atomic models. In that we discussed the Thomson model, the Rutherford model, then we discussed the radioactivity. In our next video, we'll be discussing about the atomic number, the mass number, isobar isotopes, and the drawback of Rutherford model. And then we'll further proceed to discuss some other models of atom. Till then, have a great day, take care of yourself, and thank you.